I'll let y'all out real early. 30 minutes early. 10:30. I'll let y'all out a half hour early. Maybe I should have went over new material. It bothers me that I don't know what happened to my dang test. And I hope I turned my laptop over because my cats love to walk on the keyboard. Why do they do that?
Hey, Hubert.
I get on there and the password is like 5,000 characters. I love my cats. Golly, everybody's staying on. They're not running off. Why ain't y'all running off?
Thank you, Hubert.
See y'all.
Hey, Hubert.
Yeah.
One of those questions were back in 10.1. I think it's question 7. It's the weird graph. Or chart, I'm sorry.
Yeah, I'm going to do those Thursday because I've got to sit down and do those. I hate those because I've never seen them before. You're talking about one like this?
Yes, sir. Yep, exactly.
I'm going to do those Thursday.
Okay.
I don't know where those come from. I've never seen them before. So basically, you got to take the identities and you manipulate them to look like one of these answers.
Right. Yep.
So this one's pretty simple. Use the Pythagorean identity to rewrite cosine in terms of sine. So you just got to use your Pythagorean identity, which is probably this one right here.
Okay.
And then this one, it looks like to me they're plugging it into, they're using sine over cosine. Or what is cosine? Cosine over sine? No, that's cotangent. Cotangent is cosine over sine, isn't it?
Yes, sir. Yep.
So
Okay.
rewrite cosine as, let's see, cotangent equals cosine over sine. So cosine would be cotangent times the sine. So that may be a way you could rewrite it. Or you could rewrite cosine as 1 over the secant, right? Right, 1 over the secant. And you might be able to change 1 into a Pythagorean, and then the secant on the bottom can be written as tangent squared plus 1. You see what they're doing? They're rewriting cosine in terms of other trigonometric functions and expanding it out.
Gotcha.
So
You think
I'm
that'll be
going
on
that
the test?
Thursday. Sir?
You think that'll be a test question?
No, these, if I don't particularly like the questions, I don't subject y'all to them on a test.
Fair enough. Okay.
So, but I'm going to go over these Thursday. But I would tell you on this one right here, set this equal to, let me just do it this way. Let me show you what I'm talking about. Where is my, there it is. We know that cotangent, see this right here, we know that cotangent is equal to cosine over what? Sine. So if I want the cosine by itself, then I can rewrite cosine as the sine times cotangent. Well, most of your answers here on this problem are not written like that. They're written as far as a quotient. You see that? All of those are written as quotients, right? So
Right.
That's not a quotient. This is not a quotient right here. So you gotta, this is what you say when you get here, you say, well heck, most of those answers were in quotient form. That's not gonna help me. So then you go over here and you say, bump this. Then you say, okay, cosine is equal to what? 1 over the secant. Okay, I've got my quotient. I've got 1 over the secant. You see it? All right, now 1 can be written as far as a Pythagorean identity as well as secant can be written as a Pythagorean identity. So if you take those two and you rewrite them in terms of whatever they're asking for, because that's why they're giving you a choice. See, everything's written in terms of what? Tangent and what? Cotangent. So you might be able to write these using your Pythagorean identities with, in terms of cotangent, you may be able to rewrite these in terms of 1 and in terms of secant. Do you see what I'm saying?
Yeah, I do. Yes, sir.
And we know, you know that that secant plus tangent, pull up your Pythagorean identity, Pythagorean identity. I can't spell today. We know that tangent squared minus 1 is equal to secant squared. So you could rewrite this as the square root of tangent minus 1. So I could rewrite the secant as the square root of tangent squared, or tangent, let's see, take the square root of both sides. Tangent squared, is that plus 1? Tangent squared plus 1, and that can go on the bottom. Now, I'm not saying it's right. I'm saying you have to play with it to see what you can figure out. I don't know. And then, of course, 1, you know your Pythagorean identities, all of them are equal to 1, some way, some form. Sine plus the cosine is equal to sine plus the cosine. Secant, and then there's one more. I don't know why it's not showing all 3 of them. Let me just do this.
Cotangent.
Yeah, the cotangent, and that's the one you're probably going to be looking for.
Okay.
Well, I'm trying to find it. There it is. Cotangent squared equals cosecant squared. Cotangent squared plus 1 equals cosecant squared. And you just need to, I thought there was a cotangent. Cotangent is equal to the square root of cosecant minus 1. So cotangent is equal to the square root of cosecant squared minus 1. So I could rewrite this as the square root of cosecant. No, that's cotangent. I need 1, right? Yeah, I need 1 on top. So I could rewrite this 1 as, let's see, the cotangent 1, okay, cosecant squared minus cotangent squared. So I could rewrite the top as cosecant minus cotangent squared over the square root of tangent squared plus 1. Now, that's not an option. So what I do, I crisscross through this, and I go back and I rewrite something else. It's called trial and error.
Right.
And you're going to have to work with it. Now, I've never seen that question before until this semester. So I'm going to have to go and I'm going to have to work with it so I can figure out how to get the answers that they're supplying. So you're going to have to work with it also.
Okay. I was just worried that it was getting started, so it's good to know that.
Yeah, you're going to have to play with it. And I'm going to have to play with it because, like I say, these are new questions. These top 3 questions right here, I would say probably these 4 right here, I've never seen before. Okay. So I've kept them on here so I can come back to them Thursday and I'll have them fixed for you.
Sounds good.
And send that question that you sent also. I think you already sent it.
In there.
Is this it? Yeah. Should be square of 11.
Square root of 11.
So you got the square root of 11 and they said it was wrong.
Yes. It may be a mistake in the book, maybe. I don't know.
Yeah. This right here is different. This is different. Right here is different.
Different?
Yeah, right here, 3 pi over 2. I didn't do 3 pi over 2. No wonder it's different.
Yeah, hang on a minute.
I don't think I did 3 pi over 2.
Well, I've gotten written on my paper, negative 11 over 5 of pi over 2. I wonder why it switched. Or how it switched.
Well, I didn't do the same problem. I did another problem that was sent.
Okay.
So I could have been doing Miss Mandy's problem, and it just looked like your problem. I don't
I
know.
don't know. What I've got written on my paper, here, which 12 is when we done. Negative 11, square root of 11 over 5.
Yeah, but this was different. This is different.
I agree.
This is quadrant what? That's 3 pi over 2. This is quadrant 4. 3 pi over 2 and 2 pi. So that's quadrant 4. So the tangent of beta is in the 4th quadrant. All students take calculus. So the tangent is going to be negative, which it says right here. So that means that you've got a line like this, which means opposite, and so that means that the square root, Oscar had a hunk of apple, so negative square root of 11, and this is going to be 5, and this is going to be 6. Now, I'm going to divide all 3 of these by 2, and that's going to give me 3 pi over 2, that's going to be 3 pi less than beta over 2, which is what we're looking for, less than pi. So 2 pi and 3 pi, pi, there's pi is right here. Let's say pi is right here. So 3 pi, well, that's 2 pi right there plus pi. So it's going to be between pi and 3 pi. That's 2 pi. That's 3 pi. So I guess it's going to, I'll make sure I did that right. Let me just go ahead and finish doing what I'm doing. So we know that the cosine of this function is going to be what? Oscar had a hunk, which would be 5 over 6, right? So that's going to be 5 over 6, and that's going to be 1 minus and over 1 plus cosine of 5 over 6. I'm sorry, 5 over 6, which is 6 over 6 minus 5 over 6 over 6 over 6 plus 5 over 6, which is going to be 1 over 6 over 11 over 6 multiple 6 over 11, which would be the square root of 1 over the square root of 11 multiplied by the square root of 11 over square root of 11, which is equal to the square root of 11 over 11. And what quadrant is it in? Tangent, all students take. See, I think I've messed up here. Let's see. Theta over 2 is going to be 3 pi, 8 over 2, and pi. All students take calculus. So in this case, it's going to be a negative.
Okay, so you got the right answer.
Yeah, I got the right answer, but it's supposed to be negative. But the reason they're different is because of this.
Yes, sir, I see now. My bad.
That's why I kept asking you in class. I kept saying, is it the same? And it wasn't.
Right.
It was different. But we got the negative. You see the square root of 11 over 11. That's why, because it's in a different quadrant. All right. Y'all get out of here. That's enough for making the brain hurt.
Thank you, Hubert.
All right. We'll see y'all. Tried to turn off. Did I turn off the recorder? Nope, I sure didn't. So that's extra.